So, addition rule number 1 was for mutually exclusive events. Addition rule number 2 will be for events that are not mutually exclusive. Remember, mutually exclusive represents that the two events have nothing in common with each other. Which means if they're non-mutually exclusive, there is at least one element or one outcome that both events share. When two events, A and B, are not mutually exclusive, the probability that A or B will occur is the following. The probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. So in this first video, in this first problem that we're going to do for non-mutually exclusive events, we're going to look at the elements a part of each set, the outcomes. And then in question number 3, which will also be in the same video, we will then be finding the probability of non-mutually exclusive events. Let's focus on number 2. A number cubed with faces labeled 1 to 6 is rolled once. The number rolled will be recorded as the outcome. Event A, the number rolled is less than 5. Event B, the number rolled is even. Give the outcomes for each of the following events. If there is more than one element in the set, separate them with commas. Okay, we're rolling a number cubed faces 1 through 6 once. That is a single fair die with 6 sides to it. So the sample space of that is going to be the numbers 1 through 6. Now, we want to find event A and set notation in roster form. The number rolled is less than 5. Out of the 6 numbers that are listed in this sample space, there are 4 numbers that are less than 5. And those numbers are going to be 1, 2, 3, and 4. It says, for the next one, the number rolled is even. Out of the 6 options that are listed there, we have 3 even numbers, which is 2, 4, and 6. All right. Now that we identified event A and event B, let's find the following. Event A or event B. Treat OR like the union between two sets. Once again, treat OR as the union between the two sets, between the two events. If I unite these two sets together to form one overall set, that is going to be 1, 2, 3, 4, and 6. So once again, treat OR as the union between both of those sets. Event A and B. Treat AND as the intersection of those two sets. And remember, intersection means the elements the sets have in common with each other. What does A and B have in common with each other? They both have a 2 in common, and they both have a 4 in common. Those elements are in both sets. And that is the answer to number 2. That is how you approach it, and that is how you solve it in using roster form. If you understand number 2, number 3 should also be simple, or at least easy enough for you guys to understand. Now it says here, A six-sided die with faces labeled 1 to 6 will be rolled once. The possible outcomes are listed below. Note that each outcome has the same probability. Write the probabilities as fractions. A. Check the outcomes for each event below, then enter the probability of the event. Event A says rolling an odd number. Event B says rolling a number less than 4. Event A and B says rolling an odd number and rolling a number less than 4. Event A or B says rolling an odd number or rolling a number less than 4. Let's answer those questions. And remember from the previous example, when it comes to the addition rule, the word or represents the union and the word and will represent the intersection between the events. It says for event A, roll an odd number. My odd numbers are 1, 3, and 5. What's the probability? Out of 6 possibilities, there are 3 odd numbers. The probability of an odd number is 3 out of 6. And you can reduce 3/6 to 1/2. Event B says rolling a number less than 4. There are 3 numbers less than 4, which is 1, 2, and 3. So the probability of us rolling a number less than 4 is 3 out of 6, which is once again reduced to 1/2. Event A and B, rolling an odd number and rolling a number less than 4. So you want to roll an odd number that is less than 4. Both must be applicable. That is going to be 1 and 3. Remember, and is the intersection between the events. Events A and B intersect at the number 1, and they intersect at the number 3. That's why A and B will be the numbers 1 and 3. 1 and 3 are both odd, and at the same time, 1 and 3 are numbers that are less than 4. The probability of rolling an odd number and rolling the number less than 4 is going to be 2 out of 6, and I can reduce the fraction 2/6 to 1/3. Let's reset. Now, event A or B, rolling an odd number or rolling a number that is less than 4. Or means to unite the sets together to make one overall set. So unite all the possibilities for event A with all the possibilities for event B. Put it together to form one overall computation. And when I do that, that is going to be selecting the numbers 1, 2, 3, and 5. Let's go over it. Rolling an odd number, that is 1, 3, and 5. Or gives us the options. Or rolling a number that is less than 4, which is 1. But 1 already been selected, so do not select it again. 2 is a number that is less than 4. 3 is also a number less than 4, but it was selected in the first round, so do not select it again. That is 4 possibilities out of 6. So the probability of selecting a odd number or the numbers less than 4 is 4 out of 6, which is reduced to 2/3. Now, we fill out the table. We want to complete the following. Compute the following, rather. The probability of A plus the probability of B minus the probability of A and B. Let's compute that using the information that is given up here. The probability of A, for event A, when we did it, that was 1/2. But use its non-reduced form. Use the non-reduced fraction. So that's 3/6. When I computed the probability for event B, we also got 3/6, which is also 1/2. Minus the probability of A and B. When I computed the probability for event A and B, that was 1/3, but its non-reduced form is going to be 2/6. We use the non-reduced form because they have the same denominator, and when I'm adding fractions or subtracting, we want to have the same denominator. 3/6 plus 3/6 minus 2/6. Same denominators, compute the tops. 3 plus 3 is 6. 6 minus 2 is 4. That is going to be 4/6, which is reduced to 2/3. What else is equal to 2/3? If you notice, the probability of A or B is equal to 2/3. And the reason why that is the case is because, remember, the addition rule formula, the probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. So there, by default, we already knew that the probability of A plus the probability of B minus the probability of A and B was going to equal 2/3. All right, guys, that is it to this 12-minute video. Hope that made sense. Hope you guys understand how to work the addition rule so far. We're now going to be applying the addition rule to Venn diagrams and to cards, and then we're going to see how to construct what is called a contingency table. I'll see you soon. Take care.